Okay, so like I was saying before, we are talking about exponential growth and decay. So yesterday, we had equations like this. Would this be exponential growth or decay? Okay, this would be growth. Alright, so what we're going to do today is we're going to actually write our own exponential equations based off of situation. So, you go to this page right here. If you remember growth, we did talk about a couple examples of growth yesterday, like interest, things like that, but just know, growth is something that would be increasing over time, increasing with a percentage. And then a decay is something that is decreasing. They also like to use the word depreciates. Alright, so what we're doing today, we're going to start off finding the exponential base. What all that means, that's B. Exponential base, that's your B. So that's what we're going to start off finding today. Whenever we were learning about slope, remember when we did slope and we had a slope formula, like y2 minus y1 over x2 minus x1, and then we just plug numbers into our formula? We don't get to really do that with exponential base. You have to put a little bit of thought into it, but it's not much. Alright, it's pretty simple. The first thing that you're going to do when you're trying to determine what B is you need to figure out if your situation is talking about a growth or a decay. That's the first thing you're going to do. If it's growth, then you will take 100% and you will add whatever percent they give you. If it's growth, you take 100% and you add whatever percent they give you. And then you change your answer to a decimal. If it's decay, if you read your situation and you determine that that is an exponential decay function, you will take 100% and subtract the percent that they gave you. Change your answer to a decimal. So both of these, you start with 100%, right? If it's growth, you add the percent that they give you, change your answer to a decimal. If it's decay, you subtract the percent that they gave you, change your answer to a decimal. What do both of these have in common? They both change to a decimal, and they both start with what? 100%. Okay, so let me show you how easy this is. Let's look at this example 1 right here. A car depreciates at a rate of 12%. So, the first thing you need to do is determine if this is decay or growth. This is decay. It's depreciating. This is decay. So, we start at 100%. I'm not going to put the percent sign, but that's 100%. Will we be adding or subtracting the 12%? Subtracting. So 100 minus 12, which is, with what? 88%. Change 88% to a decimal by moving starting at the percent sign, moving 2 spaces to the left. So it's 0.88. 0.88. So if you were reading a word problem like this, your B, or your exponential base, would be 0.88. So it would say 0.88 to the x power.
So it's not a...
That's how you find B.
It's not a percentage anymore?
Nope, we can't work with percents. We can start off working with percents, but you'll never plug a percent into something. You got to change it. Okay, number 2, a population increases at a rate of 32%. Is this growth or decay? Growth. So, because it's growth, I start with 100% and I add 32% to it, which gives me 132. That's not what B is, though. You got to change that to a decimal. So, because this is 132%. As a decimal, it's 1.32. That's your B. Interest rate in your bank account is 3% compounded annually. We talked about interest yesterday. Is that going to be growth or decay? Growth, okay? Interest grows. So, 3% compounded annually. You're going to start with 100, and you're going to add 3. 100% plus 3% is 103%. Change that to a decimal. 1.03. Easy, right?
Yes.
Exponential functions are the easiest ones to me. Like, they're easier than linear functions. They're easier than quadratics. The amount of caffeine in your system decreases by 21% each hour. Decreases by 21% each hour. What do you think? Growth or decay? Would you do 100 plus 21, 100 minus 21? 100 minus 21?
79.
79%. Change 79% to a decimal, 0.79. Every round, half of the tournament participants are eliminated. This is decay. So, let's see. We know we would be doing, always starting at 100%. Minus, okay, what percent would I be subtracting? 50%. Good. So I'm going to subtract 50%, which is going to give me 50%. Changing 50% to a decimal gives me 0.5. The amount of bacteria in your petri dish doubles every hour. The amount of bacteria in your petri dish doubles every hour. Is that growth or decay? Growth. Okay, so let's figure out what I'm doubling, though. Like what?
Bacteria.
Okay, I'm doubling. So I'm going to say 100%. But I need to plus something here. Plus, good, plus another 100% because I'm doubling it. So if you double 100%, that's another 100%. So that's 200%, which as a decimal, good, is 2. Do I have any questions on how to find B? You should always start with 100, determine if it's growth or decay. If it's growth, you add the percent, change it to a decimal. If it's decay, you subtract, change it to a decimal. Okay, so we got one more little part. Alright, so we know that B is only part of my exponential equation. This is my exponential equation, y equals a times b to the x power. What is a?
Starting amount.
A is the starting amount. A is the initial amount. It's how much you start with. And then B is my exponential base. What's another way that I can think about exponential base to maybe make it easier on myself?
Base count?
Almost like the slope, your rate of change, almost. Another way to think about B, your exponential base, would be like your rate of change. Okay, this is what it's changing by. Just a reminder from yesterday, if B is greater than 1, what is it?
Growth.
It's growth. If B is between 0 and 1, then it is decay. Alright, so what we're going to do for 7 through 11 is we are going to write an equation in exponential form, y equals a times b to the x power. We're going to write an equation in exponential form just based off of one little sentence here, and it's actually really easy. Let's look at number 7. A $24,000 car depreciates at a rate of 10% per year. A $24,000 car depreciates at a rate of 10% per year. So is this growth or decay?
Decay.
This is decay. Alright, So I want my equation in this format, and I know I want it in this format because it's a percent in my problem. It's increasing by a percent in my problem. So that tells me right there it's an exponential function. So what two things do I need to write it in an exponential function? Starting amount and an exponential base. Okay? So I need A and B, basically. A in this problem. What is A?
24,000.
Thank you, Omar. Can we let the rest of the class catch up? What is A in this problem? 24,000.
24,000.
Now to find B, what I'm going to do to find B is I'm going to take 100% and do what? Subtract 10%. 100% minus 10% is 90%. Change to a decimal is 0.9 or 0.90. So that is B. What did I do?
Nothing.
Stop.
So my equation is y equals 24,000 parentheses 0.9 to the x power.
That's not hard.
Alright, next one. The population of skunks in McHenry County started with 300 skunks and increases by 4% each month. So, is this growth or decay? Growth. I want my equation in y equals a times b to the x, so I know that I need a and b. What is a?
300.
Right, because it's my starting amount. And to find b, I've already determined that this is a growth, so I would do 100 plus 4, 100% plus 4%, which is 104. Change that to a decimal, 1.04. That's B. Alright, now I got A and B. I can plug it into my exponential equation. I know it's exponential because I have a percent here. So it's y equals 300 parentheses 1.04 to the x power. Next one, a stock is valued at $300. Then the value decreased by 9% each year. So you're starting at 300 and then you're decreasing by 9% each year. Is this growth or decay? This is decay. I need my A and my B, so start with A. A is 300. And then to find B, I'm going to do what? 100 minus 9, which is 91. Algebra 1 students, thank you very much. 100 minus 9 is 91%. You don't remember simple math? Like, you can write an equation of an exponential function, but you can't tell me what 100 minus 9 is. Okay. 0.91. Whew. Okay. So my equation is y equals 300 parentheses 0.91 to the x power. And this is like, on your EOC, this is how it's going to look. Like, this could be a question on your EOC. A stock is valued at $300. If the value decreases by 9% each year, which of the following exponential functions models this equation? And then, like, you would just write your equation and pick the answer. This is how it looks tested. It doesn't really get much more difficult than this. Not in Algebra 1, anyway. Algebra 2, I'm sorry. Basketball tournament.
Okay.
Starts with 124 teams. Each round, half of the competitors are eliminated. So, if you're trying to write an equation, stop. if you're trying to write an equation, you have to determine if it's growth or decay. This is what? Decay, because like they're being eliminated. Half of the teams are being eliminated. So what is A? What's your starting amount? 124. Okay, half of them are being eliminated. So that would be 100 minus 50, which is 50%. Change to a decimal, so that's 0.5. So my equation is y equals 124 parentheses 0.5 to the x power. Okay, last one that I'm going to do with you, then I'm going to let y'all practice on the other side. The population of wild moose in Wisconsin is currently at 2,000, but doubles each year. So we just talked about doubling and what that looks like. Is this growth or decay? Growth. Okay, your starting amount, or A, is 2,000. To find B, well, you start with 100%, and then you add 100% because it's doubling. So that's 200%, which when I make that a decimal, it's 2. So it would be 2,000 parentheses 2 to the x power. Okay, so this is pretty straightforward. Like it doesn't get much more difficult than this. But I want you to take a look over here, because on this side, not only do I want you to write the equation, I want you to use that equation to find like specific answers. So we're talking about buying a car and its value after each year. So what do you think you would do like with a 3, Robert?
Plug it in for the x.
Plug it in for the x, right. So the x exponent, that's what you would plug it in for. So instead of like raising, after you write your equation, how it's raised to the x power, whatever your equation is, you would raise it to the 3rd power. And see what you'll get an actual answer for it. Okay? So I want y'all to do that for this side, and check your answers when you're done. Make sure you did it right, and then put it in your notes, and then you're done. Okay? Okay.